Okay, picture this. You're walking into the exam hall. The clock is ticking, the paper is sitting right there on the desk, and your heart is probably pounding just a little bit. Welcome to the arena. Today, we're diving into a masterclass explainer where we uncover the absolute ultimate examiner's playbook. We're talking about mastering imperative procedural programming across your Cambridge Computer Science exams. Whether you're looking at syllabuses like 0417, 0478, 0983, 0984, 2210, or our main heavyweight champion today, the AS&A level 9618, the strategy remains the same. I am literally so thrilled to guide you through this today because we are going straight to the source. We're looking at exactly what examiners are desperately searching for in your answers when it comes to variables, constructs, procedures, and functions. Now, to show you what I mean, I want you to imagine two different students taking this exact paper. Let's call them Alex and Sam. Alex is the kind of student who overloads every single answer with raw computer science facts, right? Just a massive brain dump, but zero actual analysis. And then we have Sam. Sam knows the material, but Sam rushes, panics, and completely misses the command word requirements in the question. We're going to look at their flawed answers today, see the red pen marks examiners leave behind, and show you how to completely avoid their fate. This isn't just about knowing how to code, okay? It's about knowing how to prove your analytical depth on paper under pressure. So grab a mental notepad, take a deep breath, because we are stepping into the arena right now. 15%. I really want that number to sink in for a second. Did you know that this single topic, imperative procedural programming, accounts for approximately 15% of your total marks in Paper 2? That is a massive, undeniable chunk of your final grade sitting in just one conceptual area. Think about that. That 15% is literally the difference between grade boundaries. It's the difference between an average result and a top-tier standing ovation kind of grade. When Alex and Sam walk into the exam, they don't realize how heavily weighted this is, but you do. And here's the absolute best news I can give you today. Once you understand the underlying strategy behind how these specific questions are marked, that 15% becomes incredibly, almost shockingly accessible. You're not just fighting for marks anymore, you're just executing a proven system.
Here's our masterclass syllabus for today. We've got 5 key steps: the core principles, the method mark strategy, top examiner warnings, mastering algorithmic analysis, and finally, the final exam blueprint. Let's jump right in. Starting with Section 1, the core principles, analytical depth over superficial breadth.
Okay, so there is a glaring, stark contrast between how average students study and how top-tier candidates actually prepare for this exam. Let's bring our student Alex back into the picture. On the left side, we have superficial breadth. This is classic Alex. This is when you just memorize raw computer science facts, like learning syntax straight out of a textbook, but you cannot demonstrate how those pieces connect together in a real-world scenario. Alex writes down everything they know about a while loop, but completely fails to explain why it's the right choice for the specific problem. On the right side, we have what the assessment framework is actually begging for: analytical depth. Examiners are actively looking for a connected conceptual understanding. They want to see that you can take fundamental programming principles and transfer them to completely unfamiliar, weird contexts that they throw at you. They want logical, evidence-based reasoning. They do not want a list of memorized definitions. And then there's Sam. Sam reads the question, ignores the specific command words like evaluate or analyze, and just describes what the code does. That's a classic superficial breadth mistake. You have to move past the what and explain the why and the how. Which leads us to a really pressing question. Honestly, it's the core challenge of Paper 2. Why do students constantly drop points on complex problem solving and multi-step calculations? Why do students like Sam and Alex, who actually know the textbook material, still walk out of the exam hall and end up with low marks on these specific high-value questions? It's because they don't have a system. They rely on gut feeling instead of strategy. And that brings us to Section 2, the method mark strategy, systematic processing. Listen closely, because this is the secret to conquering those complex multi-step problems. It's a strict 5-step procedural framework. Examiners award you points for a visible, logical process. We call these your method marks. You have to systematically deconstruct the question. First, identify the key elements and extract the relevant data. This is where command word decoding comes in. If it says compare, you do one thing. If it says explain, you do another. Second, apply the relevant principles. Third, and this is a game changer, execute your analysis with clear working and notation. We use the Peel framework here: point, evidence, explanation, link. Make your point, back it up with code evidence, explain how it works, and link it back to the question. If you just do the math in your head, the examiner literally cannot reward your logic. Fourth, verify your results. And fifth, present your final answer in the appropriate format. If you follow this Peel framework and these 5 steps, you secure method marks even if your final calculation is a little bit off. Before we continue to dissect exactly where candidates lose these marks, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. You definitely don't want to miss the specific examiner warnings coming up next.
Moving right along to Section 3, Top Examiner Warnings, Pitfalls to Avoid.
We went straight to the principal examiner reports, and these are the top 3 absolute biggest reasons candidates hemorrhage crucial marks. Let's look at our friend Alex again. First mistake, answers are often simply too vague. Alex writes, the program runs faster. The examiner puts a big red line through it. Why? Because it's missing specific technical details. Faster how? By reducing time complexity, by optimizing memory? You have to be specific. Second mistake, forgetting to check boundary conditions and edge cases in their code. We'll talk about this in a second, but it's a massive pitfall. And third, failing to relate the answer to the specific context given in the prompt. This is SAM's biggest weakness. If the question is about a library database, your answer needs to reference the actual books and the borrowers. You can't just use generic variables like X and Y and expect top marks. You have to anchor your Peel framework right into the scenario they gave you. You're transforming those red pen marks into green check marks just by changing your perspective.
Let's double-click on that second mistake because it's absolutely crucial. You must never, ever forget your edge cases. What even is an edge case or boundary condition? It represents the extreme operating limits of an algorithm. Imagine an ATM program. What happens when the user tries to withdraw $0? What happens when they try to withdraw the absolute maximum allowed limit? Or what if, completely out of nowhere, the user types the letter A instead of a number? Practical application requires you to test these extremes thoroughly to evaluate how they affect performance and to avoid catastrophic system failures. If you don't mention edge cases in your evaluation, the examiner assumes you don't know how to properly test a program. It's that simple. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's get back into the workshop. Welcome to Section 4, Mastering Algorithmic Analysis, Evaluating Quality. Okay, time for an interactive workshop. To hit the absolute highest mark bands, you have to transition from merely writing code to actively critiquing it like a senior developer. Top-scoring candidates demonstrate higher-order evaluative thinking by analyzing the trade-offs between 2 major metrics, time complexity and space complexity. I want you to look at this table on screen. Consider this your first challenge, a 60-second visual data scan. Look at the metrics. Time complexity is all about execution speed. How fast does this algorithm run as the data grows from 10 items to 10 million items? Space complexity is about memory usage. How much of the system's RAM is it eating up? Now, here is the flaw that Sam always makes. Sam thinks an algorithm can be perfect at both. But in the real world and in the exam, you often have to trade one for the other. A much faster algorithm might chew up way more memory. A super memory-efficient algorithm might be painfully slow. Examiners expect you to explicitly acknowledge these limitations. If you can spot this trade-off in the exam data, you've just found the core trend that unlocks the top grade. And this brilliantly illustrates the absolute golden rule of evaluation. Let's do a quick speed writing challenge in our heads. When you're asked to evaluate alternatives or compare approaches, you must identify both similarities and differences. This is where Alex loses marks. Alex just lists how 2 algorithms are different, but comparative analysis requires both. You need to use comparative connectives, words like whereas, similarly, conversely, to show how they relate. Every single claim you make needs to be supported with concrete evidence from the code, and then you draw a justified conclusion. If you can write just one perfect Peel paragraph, point, evidence, explanation, link, doing exactly this, you are so far ahead of the competition it's not even funny. This is what higher order assessment actually looks like on paper.
And finally, Section 5, the final exam blueprint, synthesizing the strategy. Let's bring the whole system together.
To truly conquer the 9618 exam, your algorithmic thinking must encompass these 4 pillars, tied together with the 3 rules we've been discussing today. The 4 pillars are, first, step-by-step decomposition, breaking massive, scary problems into manageable, tiny functions and procedures. Second, smart data structure selection, choosing the exact right tool for the data at hand. Third, efficient code implementation, using crystal-clear constructs and variables. And fourth, rigorous testing and evaluation, pushing those edge cases to their absolute breaking point. Now, to execute these 4 pillars, you use the 3 rules that guarantee top marks. Rule 1, command word decoding. Know exactly what the question is asking.
Rule 2, Peel framework application. Structure your paragraphs logically. And Rule 3, your time management matrix. Don't rush like Sam and don't overwrite like Alex. Keep your eye on the clock and allocate your time based on the method marks available. Before we wrap up, I have one last massive examiner alert for you. This is a direct quote from the Principal Examiner Report, basically the cheat code to the exam. It says, candidates consistently confuse key terminology. So what's the solution? Always define your terms before using them in your extended responses. Never assume the examiner knows what you mean. And more importantly, never assume the examiner assumes you know what you mean. If you are going to talk about a specific procedural construct or recursion or passing by reference versus value, define it briefly first. It proves your conceptual understanding instantly, and it provides a rock-solid anchor for your evidence-based reasoning. It's the easiest way to show you are an analytical thinker, not just someone who memorized a textbook. So as you step into your next past paper practice session, I want you to ask yourself, are you going to act like Alex, just stating facts and hoping for the best? Or are you ready to command the arena, prove your analytical depth, show your systematic method clearly, and secure that 15%? The choice is entirely yours. Listen, students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below right now with your target grade for computer science and the absolute biggest challenge you're facing. Our team responds to every single comment. We'd love to help you out. Like and share this video with a study partner who needs to hear this. Ace the Exams, your Cambridge success starts here. I'll see you in the next one.